Okay, let's finish up warm up number 2. So we're on number 16. So on number 16, a restaurant offers a dinner special in which you can choose 1 out of 3 appetizers, 1 out of 4 entrees, 2 out of 5 side dishes, and 1 out of 6 desserts. And so the question is, how many different meals can you make with those choices? So 1 out of 3 appetizers, 1 out of 4 entrees, 2 out of 5 side dishes, and 1 out of 6 desserts. So that means here we've got 3 times 4 is 12. Oops. Yeah. 3 times 4 is 12. And then here we've got 5 times 4 divided by 2, because you're getting 2 out of the 5. So we have to rule out that you wouldn't get like double corn or something like that. So that is 5 times 4, because it's 2 different side dishes. 5 times 4 divided by 2 is equal to 10. So now I've got 12 times 10 is 120 different dinners. And now when I factor in the desserts, that gives me 720 different meals. 17. On 17, we've got 15 machines, and it takes them 15 minutes to make 500 ravioli. And the question is, how long would it take if you had 75 machines and you're making 6,000 ravioli? Well, if you have 75 machines, that means they can make 2,500 ravioli in the same amount of time, 15 minutes. So 75 machines can make 2,500 ravioli in 15 minutes. So the question is, how long would it take them then to make 6,000? So 6,000 divided by 2,500 times 15. So I can reduce this to 12 over 5 times 15, or I can say 15 over 1. Cancel here, and then multiply through. 12 times 3 is 36. So that's going to be my answer. It's going to take 36 minutes for those 75 machines to make 6,000 ravioli. 18. We've got 4 chips, and they are labeled 2, 3, 1, and 7. And we draw 2 chips at random without replacement and create a 2-digit number. What's the probability that that 2-digit number is a prime number? I think the simplest way to do this is probably to figure out how many 2-digit prime numbers you can make, and then how many non-prime numbers. So my prime numbers with those 4 digits are going to be, let's see, starting with my 1 first, 13, 17, and then with the 2, 23, and then with the 3, 31 and 37, and then with the 7, 71 and 73. So that's 1, 2, 3, 4, 5, 6, 7. And then my non-prime numbers are 12, 21, 27, 32, and 72. So 1, 2, 3, 4, 5. So that means I have a total of 12. And the question is, what's the probability that the two-digit number we pull will be prime? So that's going to be 7 out of 12. And that's 18. 19. The letters A through Z are equally spaced on a number line where A is at 0 and Z is at 25. So what's the average of the two numbers that are 4 units from the letter M? So if I have M, if I go 4 units to the left, that will get me to the letter I. And so the letter I, if you figure A is at 0, I is going to have to be at 8, which means M is going to be at 12. And if I go 4 units this way, I'll get Q, and that will have to be at 16. Well, if they're both 4 units apart, then the average of their numbers has to be 12. Last one, number 20. On a coordinate grid, point B, so another grid, point B is located 8 units below and 2 units to the left of point A, which is at 0, 6. So there's A. And B is going to be 8 units below. So this would be -2. And then 2 units to the left. So this is -2. So there's B. So this is going to be another triangle, and we're going to use Pythagorean theorem again because we want to know what's the length of AB. So if I make a triangle, AB is my hypotenuse, and I know the length of B to the origin is 2. A to here, this side, is going to be 8. So C squared is equal to 2 squared plus 8 squared, or 4 plus 64. Yeah. So that's 68. And the trick here is that they say express in the simplest radical form. So C is equal to the square root of 68. But you can simplify that because you can pull 4 out of that. So that means C is equal to square root of 4 plus, square root of 4, how do I say that? 4 times 17 is 68. So now I can say that this is equal to square root of 4 times square root of 17. So C is equal to 2 times square root of 17. And that is it for warm-up number 2.